Okay, let's solve this three-sum question. I've done this question yesterday on LeetCode. Let's do it again in the mock interview format. So let's start by creating a file. So using C++. The question is, we're going to be given an array. And we want to find all the triples such that z plus numbers k is equal to 0, and these three numbers are not the same pair. So we come up some test cases. So the first one is the input could be an array. And this time the output is given here, so it's here. Okay, so the second one, the input, we can also have some special cases like there's no actually sum of 0. So this time we're going to output an empty. So another cases that we find which might be special is we can have multiple repeated results. I mean the same triple. So for example, we have and this time the output should only be this one. Okay, so we don't need the same triple in the final result. Some constraint. So first we might have some limitation for the size of the input. We might be or maybe have some range limitation for the input. So okay, I think that's basically all about the question. And the time complexity. So time complexity, pretty much we obviously cannot solve this in linear time. So it basically you're gonna have an algorithm that solve this in not log n squared. Which is possible, I believe. So the idea is so before we start coding, so the idea is about, for example, we have an array that given here. Okay, so what we're gonna do is previously we have two-sum question. Two-sum question is basically we find two numbers that the sum of them are 0. So for that question we have I here, and j we're just going to do an iteration until the end, and then we're going to increment I. Okay, so we're going to do increment j until the end, and then we increment I again. J. Okay, so the idea is we fix one and move the other one, but for threesome we're probably going to fix one and move the other two. So different from the two-sum question, we need more information about the other two elements, because we need to know which one is larger and which one is smaller. Once we know that, we calculate the sum of these three numbers, and once the sum of these three numbers are large, we can do some operations to the other two that we are moving, and same as likewise small or equal to 0, we can also do some operations to the other two numbers that we are moving. So for the threesome questions, we're going to sort the array first. So the array is being sorted, and we have I here. We initialize j here. So the key point is we can find we fix I for each iteration, and then we move j and k. So we start from the largest one, that's the k. So the reason we do this is once we find ijk, the sum of ijk is larger, we're going to decrement k. All right. So once we find ijk, the sum of ijk is smaller, we're going to increment I. Consider I is fixed. Sorry, increment j. Consider I is fixed. All right. So in this case, -1, and 4, the sum is too large. So what we can do, we're going to increment, we're going to decrement k. This time the sum is 0, and then we do something, we push back. We push back this current combination to the result. All right, and then we continue. We continue to increment j. Okay, so this time is too large. We decrement k, and we find another one. Okay, so that's basically the logic. Now we're going to write a code here. So namespace standard using standard vector. Okay, so we have a vector type of int. So we're gonna return a vector of vector and the inner vector with type of int, right? Maybe at this stage we can add const vector int, and we pass in the reference here and numbers. Okay, and finally we're going to return the result. then the result is a vector of this type. And so the first thing we're going to do is we're going to sort the input numbers. So we do a standard standard sort, or maybe just sort, I'm not sure. Sort the array. So numbers dot begin, numbers dot end, the iterator here. Okay, so and then we're going to implement the logic for each I. So this time, for now, we consider I is fixed. Okay, so we start by initialize j is equal to I plus 1. K is the last number. All right, so k is equal to numbers dot psi minus 1. So this time, what we're gonna do, we're gonna calculate the total. All right, so if j is smaller than k, total is equal to numbers dot I plus numbers dot j plus numbers dot k. So if we find the total is too large, what we're gonna do, we're gonna decrement k. Oops. All right. So else if the total is too small, we're going to increment j. If the total is equal to 0, we're going to add the result and continue. So results dot pushback I numbers dot j numbers dot k. Okay, and continue. We're going to do plus plus. So previously when I was doing this question, I just finalized here, but I find I made a mistake because potentially there might be two numbers being the same. So for example, we have j here and k here and j here and k here. These two are same. So we add one while loop here. Well, number dot j is equal to numbers dot j minus 1. Oh, please note, we already add the j, right? So this time we have already moved the j to the next one. So this time it means if these two numbers are the same, we're going to do a j plus plus. And don't forget, j is smaller than k always. Okay. So again, these are the logic within each I. So the I is fixed at this stage. Okay. So what we're gonna do, the I is actually not fixed. We're gonna have a for loop for I. I smaller than size. Smaller than numbers dot size. I plus plus. We can to wrap it up. Okay, so I think that will be the answer, but before we testing it, there's actually one more thing to do, is the repeat element. So this test case, remember we only want the only one being printed. So yes, technically we can set a function, we can make a function here to filter out. But algorithmically we can do one thing, which is pretty simple, because similar like this, once we found two elements are the same, we skip. So we're gonna do what we're gonna do one thing. If we find and r is greater than 0 and these two numbers are the same, is equal to numbers.i minus 1. Continue. Okay, we don't execute the following code again. So looks good. We write a test case. So we're going to use some standard library for vector to make things simple. Vector input is equal to, so let's just say -4, -1, or maybe 3, 2, 1, 0. Oh, sorry. This should be vector int, isn't it? So results, or maybe we'll just say test1 is equal to a 3-sum. The function pass a parameter input. So we're gonna print those elements out for we're gonna just use const auto. Okay, let's run the program. Oops. Maybe we don't need a const here. Just this. Oops, it gave us an error. Silly one. So 92. Oops. Yep. So this is exactly what we want, right? So what we're going to do is we're going to have another test case, which is we're going to change the input. we're going to test an element with so this time they are all smaller than 0. There is no possible combination for 3 numbers which satisfy the sum of them are 0. We expect an empty output, right? Yep, it doesn't output anything. So here, we're gonna change it again. You're gonna test redundant element. So -4, 0, 4, -4, 0, 4, -4, 0, 4. This time we only expect one -4, 0, 4 being output, right? Oops, cool. Oh, we also get 0, 0, 0. Yeah, that's correct. Okay, cool. So I think we can finalize this question here.